Greetings everyone! In this tutorial we're going to go over how to create this pulley system in SolidWorks. We'll start by using the belt chain assembly feature to link all of our pulleys together so they rotate in unison, kind of like a gear mate. Then we'll create our physical belt using the sketch created from our belt chain feature and a simple sweep. This will be a great tutorial for anyone planning on taking the Certified SolidWorks Expert Exam, as belts and chains are one of the possible topics they'll ask you about on the test. Before we get started, please be sure to hit the like button and subscribe to get notifications about future videos on the channel. It really helps us out here at Krawchuk Industries. Also be sure to comment with any suggestions for future tutorials that you would like to see. Now let's get started. To create our belt feature, we're going to go to Insert, Assembly Features, and select Belt Chain. And we have to select our belt members, which is just a closed loop of arcs that the belt will contact. We're going to select the inner groove of our pulleys for this. As we select the different pulleys, you see that the projected sketch of the belt is starting to take shape. It's important to select the belt members in a sequentially ordered loop, otherwise they might get twisted. So there we have our proper belt, but if we were to clear our selections and select them in a random order, we see that the belt can quickly get tangled, like so, which is no good. So we'll clear our selections again, and we'll just select in this sequence here. And there we go. And we have a few more options here. We can set the diameter of our pulley. It's automatically pulling 1.5 inches from the physical pulley part, but if we wanted to customize that, we could. We could also flip the side of the pulley that the belt is on, like so. We would use that mostly if it glitched when we were selecting them and put the belt on the wrong side. We can also select a belt location plane. This is a plane to offset the sketch for our belt if we wanted to. We won't need that, so we'll keep it on the pulleys themselves. And then we have a few properties down here. The belt length is shown here. If the position of the pulleys is not fully defined, the length can actually be driven and the pulley position will update to accommodate the length. It also gives you the actual length of the belt here, so it should be 41.53 inches. And we can use our belt thickness if we wanted to. This would offset the belt from the surface if, say, you were using a specific thickness. Engage belt will create a belt mate between all of our pulleys so that they rotate in unison. And create belt part creates a physical part that the sketch will be in our feature tree. So we're going to select Engage belt and create belt part, because we want to create our physical belt for this example. And we'll hit the green checkbox. And you should get a pop-up window to create your part for your belt. So we want to know what template to use. So we're just going to use our basic part template that comes with SolidWorks and hit OK. We now see that we have a sketch here for our belt, and that if we rotate our pulleys, they all rotate in unison with one another, as if a belt was linking them. On our feature tree, we have a new feature, a belt with its length. And if we expand it out, we have our sketch, and then we have a belt part here. And if we expand that out, it just has a derived sketch based off of the sketch from the belt feature. Now that we've created our belt feature, we can use it to create our physical belt. Let's start by opening up the belt part where we just have the derived sketch. And we're going to use this sketch to create a sweep for our belt, but we need to create our profile sketch first. And to do this, we're going to need to create a plane that is perpendicular to our sketch. So we're going to go up to Features and go to Reference Geometry and select Plane. For the first reference, we'll pick this line here, and we will set it to be perpendicular. And for the second reference, to fully define the plane, we're going to pick the endpoint for this arc right here. Now that our plane is fully defined, we'll hit the green checkbox and then go to Sketch to create a new sketch on our plane. We will go Normal 2, and start our sketch for our V-belt. So we're going to actually start with a midpoint line, like so, and then just a normal line like that, a horizontal line, and another tapered line. And we're going to add a center line that runs from the center point there to the midpoint of our top line. And we'll double click to close out our line segment. And we'll make this center line vertical. And we're going to hold Control and select our two outer lines and the center line, and we're going to make them symmetrical to one another so that as we move one, the other one follows, like so. Now we're ready to start adding our physical dimensions. So we'll go up here to Smart Dimension. Our top edge is going to be 0.5 inches. Our bottom edge is going to be 0.19 inches. And our belt height is going to be 0.5 inches. And we'll hit Escape to close our dimension tool. Now we need to fully define the position of our sketch. So we're going to hold down Control, select the bottom midpoint, and then select the origin, and then make them coincident, like so. And now our sketch is fully defined. So we will hit the green checkbox and exit our sketch. So now we need to create our sweep. To do this, we're going to go up to Features, Sweep Boss Base. It automatically selects the sketch we just created for our profile. For our path, we're going to expand our feature tree and select the sketch 2 and hit OK. So now we have our basic model, but it doesn't look quite right. So let's set our material to rubber. So we'll right click, go to Edit Material, and go down to Other Non-Metals from the standard files that come with SolidWorks, and select Rubber, and hit Apply, and Close. So now, if we go back to our pulley system and update, we see that we have a belt in place. Now the belt will not actually move when we spin the pulleys, but for things like animations, it will create the appearance of a correct part. And if we adjust the angle of our idler pulley here, so we'll go by adjusting the arm, so if we change this angle here from 150 to, let's say, 160 and hit refresh, we see that the belt has updated dynamically with it. Thank you very much for watching this tutorial. I hope you learned a few new things about the belt feature that will help you when you take your CSWE exam. Again, if you enjoyed the video, please be sure to hit the like button and subscribe. It really helps us out on the channel. And be sure to check out the other great SolidWorks tutorials that have already been posted. Thank you and have a great day.